Hello everyone, and today we'll be covering chemical and physical properties. To begin, physical properties are characteristics that you can observe or measure without changing the substance. So this last sentence, in particular, without changing the substance, is really important because it's what distinguishes physical properties from chemical properties. So to begin, there are two primary types: quantitative, which I should probably change this, but it's characteristics that could be observed and measured. Because usually, for example, say solubility, you could observe it and you can measure it. Second off, quantitative, which are characteristics that you can only observe. So to begin with qualitative physical properties, one of the major ones we have is color. As you can see, yellow, red, green, blue. Odor. If you take a whiff of a flower, you could say it's sweet, pungent, floral. Texture, whether something is rough or whether something is smooth. State, water is a really common one. Water is a liquid, ice is a solid, and water vapor is a gas. Luster, whether something is shiny or dull. Hardness, the ability to scratch another material, whether it's hard or soft. So if we compare, say, paper and rock, you'll see that there will be maybe invariable hardness and yeah, opacity. So as you can see, A, B, and C, A is transparent, B is translucent, and C is opaque, which means that you can't see through it whatsoever. Now, malleability, this one's a difficult one because it coincides with the next one, ductility. So, malleability is basically how easily a metal could be bent or flattened without breaking. Ductility is how easily it can be stretched into a wire without breaking. So, um, on test questions, usually the teacher expects you to put one of these, and it depends on the context. Okay, iron, for example, is malleable and ductile. Same goes for gold. Um, it depends on what the teacher wants you to do, and they'll usually specify it in class. Now, let's move on to quantitative physical properties. We have viscosity. So, I find a really easy way to distinguish qualitative from quantitative physical properties is their association with numbers. If you take a look at viscosity, think to yourself, is there a way to measure the viscosity of said material? Water, for example, is very low viscosity. Maple syrup is very high. Take a look at the picture. The one on the right is flowing really slowly. It's high viscosity, while the liquid on the left is very low viscosity. Melting point. Of course, there's a number that is associated with this. Boiling point two, at what temperature, which is represented by a number. That's a liquid boils at. Solubility. So this one is very commonly confused as a qualitative physical property. But the thing is, solubility is indeed a quantitative physical property. I'll give you an example. If you have a 5 milliliters of water and you fill it to the brim with salt, it will only be 33% soluble because the mass of the salt outweighs that of the water. Of course, solute, solvent, solution. Um, Conductivity, this is another one that's very confusing. Yes, you have to understand the ability to conduct electricity or heat can be measured. There is a formula, there's a theorem for this. And of course, density, straight up, D equals M over V. So, as I said, it's very easy to understand what is a quantitative physical property, except for solubility and conductivity. It's by knowing if it's associated with a number or if it's associated with a theorem. Now, going on to chemical properties. So it's the ability of a substance to change slash react and create new substances. So this is really important in chemistry, where most of what you're going to do involves chemical properties. So combustibility. Let's go back to our definition here. Make new substances. It's highlighted and bolded here. So combustibility is the ability of a substance to burn in air. For example, wood, paper, rubber. It's all very combustible. Now, when you burn wood, the very chemical bonds are changed. It becomes ash and thus a new substance. Now, reactivity with water, sodium plus water equals an explosion. This is very obvious. Um, something new is being created. In most cases, it could be CO2, it could be, for example, say ash. These new materials or substances hint towards it being a chemical property. Now, let me give you another example. Aluminum and oxygen slash reactivity with oxygen. So, of course, oxidation of different substances is a form of chemical property because something reacts, something changes within the very compounds and within the bonds of the material. Now, reactivity with acids. So, this is a very common one. Baking soda plus acid. This is a chemical reaction because, as you can see in the video, CO2 bubbles are created. Usually when we think of CO2 bubbles, we don't think of something new is being created, but something is. And that's everything. So just as a recap, in order to distinguish a quantitative physical property from a qualitative physical property, you have to essentially see if said property is associated with a number, a theory, or a formula. And in order to distinguish a physical property from a chemical property, you have to think, does it make a new substance? Does something react? Does something change based on what makes up the substance? And that's about it. So